Alright, in this video we're going to be talking about nullable value types in C#. Nullable value types are a way to assign null, the null constant, to any value type that you have a variable of. And the reasons you might want to use this are mainly in both configuration and access to our DBMSs. Those are the two examples that come to mind, where in configuration you might have a value type such as a Boolean, and you would want the user to be able to specify that Boolean or optionally not specify it and have your code provide a default value. In that case, it's actually a little bit difficult to do because by default Booleans cannot be null. In addition, in all RDBMSs that, well, I know of, you can have each column, even if it is a value type such as int or Boolean or bit or whatever types you have available to you, you can allow those columns to be null. So in order to represent those values in C#, there must be some sort of way to represent a nullable value type. So I'm going to go ahead and fire up a new project, and we can see what it looks like. So nullability of value types in C# is actually a combination of a built-in, or not a built-in type, but a .NET type, and a bunch of special syntax that the C# compiler lets us do. By default, I can't declare a Boolean variable and give it a name, and then assign it to null. That is invalid. This will be invalid if I was using any of the built-in types. This would be invalid if I was using any structures or any enumerations. I just can't assign that value to null. What I could do is I could do nullable of type Boolean and assign this to null. This is proper syntax because the C# compiler will actually go out and instantiate this nullable type and assign one of its properties to false, specifying that it has a null value. There is a shorthand syntax for this in C# where I can say bool C equals null, and these two lines are perfectly equivalent.
So basically system.nullable is just a generic wrapper class for a value type.
Yes.
Okay.
But it's interesting to note actually that system.nullable is a value type itself.
Okay.
Doing this will simply set its has value property to false. So for example, I could do C dot, and you see that we have this has value property. This has value property is set to true or false depending on if the actual thing that it's assigned to is null, if it's actually assigned to null in any case. Value is a way to access the underlying value of the nullable type or the nullable variable. Now, it's important to know that if I were to call value where has value is false, I would get a system.invalid operation exception. These two properties are actually accessed by the C# compiler depending on certain syntax that you might use. In addition, the actual terminology of assigning a non-null value to a nullable type, so for example, this syntax is actually an implicit conversion done by the nullable type. It actually translates into something like this. But basically what this is called wrapping. So we are wrapping this value into this nullable wrapper. The process of accessing this value property is the process of unwrapping. So yeah. So basically, an example that we could use to sort of demonstrate why you might use nullable types, and to go back to the configuration example, we might have a method called getIsFullScreen. And we can pretend that fullscreen is a configuration value that's set in a file, and we allow that configuration value to not be set in cases where a person wants to use the default behavior. In order to cleanly define the default behavior of this option, we can just do this. Yeah. Okay, so we can just do this. Our default in this case is false. Using the null coalescence operator, we'll actually go out and invoke. This won't actually compare getIsFullScreen to null. Remember, you can't actually do that Well, you can, but you can't technically, because what I mean is nullable system.nullable is a value type itself. What this is actually doing is this is implicitly converting get as full screen, or not implicitly converting, but comparing it to null. And when a nullable value type is compared to null, the C# compiler generates code that checks the has value property of the nullable type. Then finally, it's going to be converted if it's not null, or if it is null, sorry, we will use this default value that we specified on the right operand of the null coalescing operator. As far as the actual type of this, it's interesting. We can see right here that it's a system.boolean. It is not a system.nullable of type system.boolean. It's just a system.boolean. That's because when we there's an implicit conversion between a nullable t and a t. And the result of that implicit conversion will always be of type t, if that makes sense.
Mm-hmm.
So the other instances where the C# compiler actually goes out and generates code for us, if we were to do if d is null, what's going on here is the C# compiler will actually generate code that looks like this. If not d.hasValue. So basically, if the C# compiler cannot find a operator in which it can actually invoke user-defined code in this case, it will do this. It'll generate out code that uses the hasValue property to determine the nullness of your variable. So as far as nullable values are concerned, that's really about it. There are implicit and explicit conversions that work with nullable types. You can implicitly convert between two nullable types that have implicit conversions, or you can explicitly convert from a nullable type to a non-nullable type as long as an implicit or explicit conversion exists on that type.
Okay, very cool. Well, with that, that will wrap up this video on nullable value types. Thanks a lot.